Good evening, students. My name is Chandan Ghosh, and welcome to my YouTube channel, Mathematrics. Today, we'll be discussing one of the most important topic in 10 plus 2 level, which is permutations and combinations. Let's begin. So, permutations and combinations are basically mathematical methods to count the number of ways you can choose and arrange a set of distinct objects from a group of distinct objects. Couple of things to just remember here. Let me make a note of those important things here. One is choose and arrange, and distinct object. This one. We'll explain everything in later point in time when we'll go deeper into this. But one thing to mention here, permutation is basically choose plus arrange. Just remember this. And combination or choose only. And you have to choose distinct objects from a set of group of distinct objects. So if the objects are not distinct, then you cannot use permutations or combinations. Now, we need to understand a couple of things which will be used in order to solve your permutations or combinations problem. Let's start with factorial. Some of you may have heard what factorial is, and it's denoted as, let me write it over here, factorial. It's denoted as, let's say, n factorial. So factorial is used to find how many ways the object can be arranged. It's used how many ways objects can be arranged. Let me give you an example. Let's say you do have 3 different comic books from 3 different authors, and you have been asked to arrange the possible ways in the shelf. So how many such ways you can arrange? So 3 books, let's say. The first one by author B, second one by C, third one B, third one by C. So how many such arrangements you can make? So it could be A, B, C, or it could be A, C, B, or B, A, C, B, C, A, or it could be C, A, B, or C, B, A. So how many ways it can be arranged? So 6 ways. If you have two books by author A and B, so how many different ways you can arrange them? Let's say you have 2, A and B. So you can arrange them either AB or BA. Likewise, if you have 4, let me write it over here. Let me make a note of that. If you have 2 objects, they can be arranged in 2 different ways. If you have 3 objects, they can be arranged in 6 different ways. If you have 4 such object, how many different ways we can arrange them? Those are A, B, C and D. Okay. So let me begin with A. If I start with A, the next one, let me try this with branching method. Or let me put it this way. You do have 4 different letters, A, B, C and D, and you have been asked how many different words you can form of these 4 letters. So which is nothing but, same way, other way around. You have 4 books, how many different ways you can arrange them in the cell. So I have 4 different books, how can I arrange them? So how many words can be formed using these 4 letters? Let's start. The first position is A. So remaining place, there are 3 places. I do have B, C, D. How many different ways I can fill this position? 6. We have seen that. So starting with A, we can have 6 different distinct words. Likewise, B. So remaining 3 places can be filled with 6 different ways again. So with B, another 6, C, another 6, D, another 6. So I'll have total 24 distinct words can be formed using A, B, C and D. Now, so if I have 4 letters, I'll have 24 ways. How can you put it this way? This is nothing but 3 factorial, this is 4 factorial, so on and so forth. 2 factorial is nothing but 2 into 1. 3 factorial is 3 into 2 into 1. 4 factorial is 4 into 3 into 2. N factorial is n times n minus 1 times n minus 2. N is integers all the way till 1. So this is a factorial. So point to note here, if you have been given n distinct letters, so you can, and you have been asked how many ways you can arrange n distinct letters. So what should be the answer? It should be factorial n. And also this factorial is an extension, let me take a note. Factorial is an extension of, fundamental principle of counting. We'll understand this in the coming video. So what for that we need to understand what is the fundamental principle of counting. We'll go in detail. So this is very important principle for your counting, which is fundamental principles of counting. What exactly it is? It uses 2 operations, either multiplications or addition, to determine the number of ways to accomplish a task. So as I said, it's fine to note here, it uses either multiplications or additions to determine the number of ways. So what's the principle of addition? Let me write it over here. Principle of addition. Let's event A occur in M ways. I'll explain that. In M ways and another event which is mutually exclusive. I'll explain what is mutually exclusive. B occur in ways then either one of the two events can be done in plus in ways. And as I said, what is A and B has to be mutually exclusive. What is mutually exclusive? Two events are called mutually exclusive if they cannot occur at the same time. Let's say at a given point in time, can it be that you are in school at the time you are at home? It cannot possible for a given point in time. So these two events are mutually exclusive. So let's say in the morning 6:30, either you are in school or you are at home. So these two events are mutually exclusive. If A such event occurs in n ways, B another events n ways, then either one of these two events can be done in n plus n ways. Let me give you an example so it will be easy to understand for you guys. So let's understand this principle of addition through an example. Let's say Spandan is in this room, the room having total 5 doors. Left hand side there are 2 doors and right hand side there are 3 doors. So now the question is how many different ways Spandan can exit the room. So how many events? There are 2 events are there. Event A, there are 2 doors on the left hand side. Event B, there are 3 doors on the right hand side. So these 2 events are mutually exclusive because at a given point in time, Spandan cannot exit through both the end. Either he will take left hand side or right hand side. Yes. So how many ways he can exit the room? It should be 5. So Spandan can exit in 3 plus 2, 5 ways. So here this is the principle of addition. So when 2 events are mutually exclusive, then this adds. And also you should understand the conjunction as well. So Spandan can exit either A or B. If it's an OR conjunction, then just take a note of this. If it's an OR conjunction, then it's an addition. Likewise, I'll explain when I'll come to principle of multiplication. In there, instead of mutually exclusive, those 2 events has to be independent and there should be an AND conjunction. So take a note. It should be OR conjunction here, and for multiplication that would be a AND conjunctions. The next is principle of multiplications. So what exactly is that? Let's say I do have 2 events, A and B, where A events can be done in M ways and B can be done in N ways, but that has to be in succession. First, A event can be done in M ways, following to this B in N ways, then two events can be occurred in succession. Point to remember, it has to be in succession. In n times n cross n ways. N times n ways. And here A and B, these are independent events. And as I said that here this is an AND conjunction. So it's an AND conjunction here. So here from A to A in n ways and B is n ways. It will be more clearer if I give these examples. Let me combine these two and put it in a single example. Let's understand these fundamental principles of counting through a different example. Let's begin. I'm traveling from Patna to Singapore via Qatar or Rome. Okay, so I'm traveling. This is my initial point. This is my termination point. I'm traveling from Patna to Singapore via Q, Qatar or Rome. Let's assume there are three different routes from Patna to Qatar, and then two different routes from Qatar to Singapore, and from Patna to Rome there are four different ways, and from Rome to Singapore another two different ways. Now how many different ways I can travel from Patna to P to S? So what are the options? I can travel P to S via Q. How many different ways are there? How many different ways I can travel from P to Q or P to S via Q? There are three paths here from P to S. One, let's say name it as P1, P2 and P3, and name these two as Q1, Q2. So how many different ways? From P to S there are three different ways. From Q to S there are two different ways. So in succession, how many ways I have from P to S via Q? It has to be 3 times 2 means 6 ways. How come 6? Let's say I am taking P1. For P1 I reach Q, and then I can take either Q1 or Q2. So for P1 I do have two routes here. Like for P1 I can take Q1 or Q2. So there are two ways. Likewise for P2 I do have two ways. For P3 I do have two ways. So I have total 6 ways, which is 3 cross 3 times 2. Yes. So let me make a note of this. From P to S via Q I do have 6 ways. Similarly, from P to S via R, I have P to S via R. I have 3, 4. Let's say this one R, R1, R2, R3, R4, and these are S1, S2. So for R1 I do have 2, for R2 2, R3 and so on. So there will be 4 cross 2 8 ways. Okay. So in this example we can define both fundamental principles of counting multiplication as well as addition. So when it is multiplication, as I said, if I move from P to S via Q, so this is a multiplication. Why this is multiplication? Because this is an AND conjunction. From P to S, how can you travel P to S? You have to travel P to Q first and Q to S. P to Q first and Q to S. So it's an AND conjunction. And these two events are independent. Why these two are independent? Because I have no restriction of my path. I can take P1, P2, P3, any of from P to Q. It will not restrict me from choosing Q1 or Q2. So that's why these two events are independent events. Likewise, same here, if I travel from P to S via Q, so there are 4 times 2, 8 ways. Again, this is a problem of multiplications because it's an AND conjunction. If I need to travel P to S via R, it has to be P to R and R to S. So from P to Q, now how can you explain the fundamental principle of addition? So what we have seen in earlier example, these two events has to be mutually exclusive. Let me put it this way. I need to travel P to S. So there are two options. I can travel via Q or via R. So it's an OR conjunction. I can travel P to S via Q and these two are mutually exclusive because at the same time I cannot travel via Q and R. So it satisfies those conditions. So my travel, how many different ways I can travel from P to S? There should be 6 plus 8. Means it should be 14 different ways I can travel from P to S via Q or R. So through this example, I think it clarifies how this principle of multiplication as well as principle of addition works and what are the key points to remember here. Thank you.